Hello everyone, welcome back to 5.3, and today we're going to try to start with modeling flat rate and depreciation with recurrence relation. So sometimes we can actually minus the depreciation periods, which is we multiply by each times of period two times the depreciation numbers. Um, so formula we actually using as um, v in equal to v0 minus nd. But sometimes we do each individual periods, which is we're gonna try to calculate each individuals, which is we use n plus one equal to v n minus d. Um, let's start the first example here. First one we do is with some companies first, and sometimes we have some depreciations documents, which is like some question with what's the $15,000 chosen to depreciate it in a flat rate method. Depreciation was 15% of cost price each year, and useful life was 5 years. So first number was like calculated annual depreciation. So we need to figure out each year where we actually depreciate how much money. So we say it's 15% cost each year, and which is we can use $15,000 multiplied by 15%, which is using the calculator we can say is around equal to 2,250. Um, so that's the annual depreciation. And then set up the recurrence relation, which is representing the depreciations, which is we using the recurrence relation. So V and plus 1 equal to Vn minus D, and V0 equal to $15,000 if you want to write down. So Vn plus 1 equal to $15,000, which is Vn, V0, sorry, Vn minus 2,205, so $50 as a recurrence relation. And we can use that to drawing the picture as well. So so first thing first you need to do is calculate the V1, V2, V3, and so on until to go into zero. Then you draw in the value which is like value, and also we have is period, so which is here. Um, period. So 5 years, which is 0, 1, 2, 3, 4, and 5. And you calculate V4, V5, V6, and so on and so on. So clearly you can say it's going to a straight line, so which is start with $15,000, 0, and then going to 1, which is 112,750, which is here. And basically we can just keep going like that, if I say that. Yeah. And this is a depreciation, which is each dot point, dot point, dot point, dot point, dot point. So then you just find your values, and then you should be able to write down your depreciation. What's that? Um, So basically, the question will ask you that, and then identify graph which is going to depreciate it each year as a similar numbers, which is with 2,250, and then using that to analyzing that as a linear relation, basically. Um, Hopefully that kind of makes sense. Later on, we're using some like a geometric sequence, which is we're using that as the curve, which is not non-linear relation. All right, example 2. So we have each year the $15,000, and the market value will be 7,500. So which is we drop by half the money. Now we're gonna try to have a look at it. Um, how are we gonna solve the total depreciation rate? So rate equal to total divided by number of year. So what does that mean is we need to find the total depreciation. So total depreciation equal to cost the price minus the current price. That's the thing. So which means that equal to $15,000 minus 7,500. So that equal to 7,500. So which is 7,500 divided by how many years we do have is 5 years. And then that means 1.5k per year, or we say 1,500 per year. Hopefully that kind of makes sense. Now what we do is be equal to Vn plus 1 equal to Vn minus d, and which is V0 equal to $15,000, and Vn plus 1 equal to Vn minus $1,500. Yep. And calculate when the value is equal to 3,000, which is when Vn plus 1 equal to 3,000. And when Vn equal to 3,000, and what is the Vn equals basically. So they try to ask you to determine when the car is equals. Okay, so for those questions just straight away, so this is equal to 5,000. Okay, then we just straight away to go into the new document. We're using car. So first you have $15,000 equal to D1 minus 1,500. So then fill, just go straight, fill, keep going, fill again, and fill again. So basically it's on V8, so which is I would say it's 7 years after. So because it's V8, so V8 equal to 30,000. So all that means is 7 years and equal to 7. Hopefully that kind of makes sense. Yeah, and then now what we do is we go into the exam questions. So first question is pretty similar with the first examples. Let's do one question, and then the question 2 and 3 you guys can figure out yourself. So question A, which is like among the dollars, a value of some medicine decreases each year. So what we do is we have pretty much like V1 equal to V0 minus 15,000. And this is about amount of dollars, and what does it decreasing each year? So basically $15,000 each year. Showing the recurrence calculation, which is machine dollars after 2 years. So you just need to find a V2 equals V1 minus the $15,000. So what we're using is we could using the another the we're using maybe just using another dollars and least squares, which is we see M medicine, which is the 15. Sorry, it's 12,000,000. And then next one equal to A1 minus $15,000 and many data and field. So which is the after 2 years that will be $90,000. No, sorry, $90,000. That's the big questions. And annual flat rate, which percentage? We're gonna try to find flat rate percentage. So what we do is we're using the depreciation money to over the total money to multiply by 100%. So once you calculate it, that's called flat rate equal to flat rate as percentage. After that calculation, 12.5% will be the flat rate. And the value of the machine dollars, which is also the value of form and A plus BN. So we're using the different forms now. And what we could do is we could just using the we could just using Vn equal to A plus Bn. Okay, so the machine dollars in here could be the root form and write down what's the root for Vn. So the value in dollars and then here's okay, determine the form, which is we already kind of know these questions. So yeah, so what we do is we're using that Vn equal to okay, so A is actually equal to $1,200,000, and B, which is what we have, is minus $15,000 and multiplied by n. So which is that how that works, and that's how you write down the Vn. So question D is Vn equal to $1,200,000 and minus the 15,000 times n. So that's the basic rule, and I think that will happen. Question 2 and C3, you guys can figure it out as well. It's not going to be very, very complicated, so please let me know your answer. Hopefully that all can make sense. I see you guys.